Today we're looking at the types of angles, and we're looking how to copy and bisect an angle. So how do I copy and bisect angles is the essential question. I'm learning to identify different types of angles, and to copy and bisect angles is our learning intention. You have two warm-up questions. The first question is over segment addition. You're to find x and then find the measure of DE. The second one is using or applying the quadratic formula. So pause the video and see if you can do those two warm-up questions now. Well, I hope you tried on your own. We know that according to segment addition, the whole length is equal to the sum of the pieces. So 3x minus 28 plus 3x minus 30 plus x is equal to 33. Combine your like terms. 3x plus 3x is 6x, plus 1 more x is 7x. Negative 28 plus negative 30 is negative 58, is equal to 33. Any questions? Okay, let's solve for x. Step 1, you're going to add 58 to both sides. I've eliminated it. 7x is equal to, so that'll be 3 plus 8 is 11, carry a 1. 3 plus 5 is 8, plus 1 more is 90. So that gives me 91. Last step is to divide by 7. Okay, 91 divided by 7, 90 is the same as 70 plus 21. 70 divided by 7 is 10. 21 divided by 7 is 3. So x is equal to 13. Now to find the measure of DE, we have to choose the correct expression. 3x minus 28 is equal to 3 times 13 minus 28. 39 minus 28. Okay, 39 minus 28 is 11. So this piece is 11. This piece is 13. That would give us 24, and that would leave 9 for this piece here. So as you're looking at it, there's different ways to come up with the answer, but when you're looking at segment addition, you still have to add all the pieces together and simplify, then solve. Quadratic formula, we're still working on it, and we're still struggling. For the quadratic formula, the first thing you do is to find that discriminant. The discriminant tells you if there's going to even be a solution. So, let's get started. Step 1, identify A, B, and C. Step 1 is actually to make sure it's set up equal to 0. If it's not set up equal to 0, that is your first step. So as I'm looking at this, I'm going to minus 10x, and I'm going to minus 1. (3x squared) minus negative 2x minus 10 more is negative 12x. 5 minus 1 is 4. 3x squared minus 12x plus 4 is equal to 0. Now I'm ready to start I'll identify A, B, and C. A is equal to 3, B is equal to negative 12, C is equal to 4. For my discriminant, you notice I've got it right here. My discriminant is equal to negative 12 quantity squared minus 4 times 3 times 4. Okay, and I end up with 96. Now, 96 is greater than 0, so I know I've got two solutions, but it is not a perfect square. So when I take the square root of 96, I've got to find its prime factorization. So, I want to take 96. Is it even? Yes, so I can divide by 2. Okay, I've got 48. Is 48 even? Yes, it is. I can divide by 2 again. I get 24. Is 24 even? Yes. Divide by 2 again. You get 12. Is 12 even? Yes. Divide by 2 again. You get 6. The factors of 6 are 2 times 3. 3 is a prime. When I hit 1, I am done. So if you take 2 times 2 times 2 times 2 times 2 times 3, you will get 96. So I've got a pair of 2's. I've got another pair of 2's, but the 2 and the 3 do not match up. So this is the square root of 96 is equal to 2 times 2 square root of 2 times 3. Take a minute and look and realize what's happening. You always start with the smallest prime number that will go into the number you're looking at. You factor that out until you cannot factor it out, and then you looked at the next prime number. That's why it's called prime factorization. 2 times 2 is 4. Square root of 6. 2 times 3 is 6. Okay, now we're ready to finish it up. The answer will be in this form, but we'll just leave the plus and minus because we are looking for the exact answer. So what is the opposite of negative 12? That's 12. Plus or minus the 4 square root of 6. If you're looking, this number here is what we've got right here. All over 2 times 3. Step 2, once you get it plugged, you need to look and think, is there a common factor? Well, you've got a factor of 2 in all of your terms. So 2 divided by 2 is 1. 12 divided by 2 is 6. 4 divided by 2 is 2. Last step is that simplification. 6 plus or minus 2 square root of 6 all over 3. And we're done. So right now we've kind of switched gears and gone from doing a lot of algebra to we're looking at geometry. So there's new things in geometry that you need to learn. If we are looking at a reflex angle of an acute angle, Okay, this is my acute angle. Because it is less than 90 degrees. So, and it's greater than 0 and less than 90. So the reflex angle of an acute angle, the angle measure will be greater than, what do you think? 180 degrees. But less than, how many degrees are in a circle? 360 degrees. So this is your reflex angle, which is the one on the outside. And it's got to be greater than 180, but still less than 360. Now, to copy anything in geometry, to copy anything, you have got to have equal distances. So the first thing we're going to do is to think about how we can create those equal distances. We need our compass, and we need to think. So step one is to draw the base. Remember, angles go on forever and ever. So that would be our bottom ray. Okay, now how do we know how big that angle is? Well, we're going to use those equidistances. So, using my compass, I'm going to make sure that I do an arc all the way through. This gives me 2 points that I can use to measure. I have to do this same arc on my vertex here because I need that same measurement. Could I have made a complete circle? Yes, I could have. Did I need a complete circle? No, but it wouldn't have hurt. Okay, so I've now got matching arcs. I now need the length. This is where I have to do my precision. I need the length from here to where it intersects up here. So I'll loosen. Whoops, it kind of went out a little bit there. This is where you've got to be careful. Now, I've got that intersecting arcs. I'm going to come here and do that same intersecting arc measure. I started over here, I found that measurement. I come over here and I do the same measurement. To finish my angle up, I go from my vertex through that point of intersection. Now, this one has one arc, and this one's going to have one arc too, to tell my readers I have constructed it in such a way that those two angles are congruent. Draw your line, draw that first arc, measure to get that second arc, draw your other ray through the intersection of that second arc. Okay, now we've talked about it before. I don't know if you remember though. How do we bisect an angle? What does angle bisector mean? Break the word bisector down. Bi means how many parts? 2. Sections, sector means sections. So, how do we cut an angle into two equal sections? It all is done with an equidistance. Remember that equal distance. So the first thing I'm going to do is to draw an arc. As you can see, I'm at a measurement that is too big. So all I do is make it a little smaller. Does it matter how small? Not really. So the first thing I'm going to do is to do this first arc that intersects both rays. Remember, it's got to be equidistant. So to get the equidistance, if I go here and make an arc, and then come down here without changing my length, make my second arc, then that point is the same, the point of intersection is the same distance from these 2 points. These 2 points are the same distance from the vertex. I've now created a angle bisector. And I will say this angle is congruent to this angle. Use those 2 tick marks. Okay, now that you've seen me do it, let's see if you can copy and bisect the angle ABC. Pause the video. If you need to, back it up and see how I did the copying. And then copy the angle first. Once you copy it, then you'll be able to bisect. Pause the video and copy the angle. Well, I hope you tried. I'm going to start off with drawing my first ray. Could have made it a little bit bigger, but it will be fine. So now, to make the first one, to get that other ray in that equal distance, I'm going to do an arc all the way across. So my points of intersection are here and here. Here's my vertex. I've got to have that same arc, so without ever changing my length, I'm going to get that first arc going. Now, to get the length, I've got to make that adjustment by finding out how far it is to this point here. Now this is a tricky one because you got to hold it steady while you tighten it down. Yep, I might be a little bit off. I'm going to adjust it down just a hair. I'm adjusting it as I'm holding it on that point. So here's my point of intersection. Remember, I've gone to this point here. Once again, my point of intersection. Ooh, what did I do wrong? I'm going to have to readjust. Remember, we don't always get it right the first time. That's okay. It is a learning process. I'm going to come just a little bit right there. Get it back on my arc. Okay. Now, this tells me I should have moved it over a little bit, but I didn't. So you might want to move it over a little bit. Okay, Those are congruent angles. This one has one tick mark. This one has one tick mark. This is angle ABC. Let's call this one angle D. Now, to do that perpendicular bisector, I've copied it. I can bisect either one of these. It doesn't matter. So, if I'm looking at it, I already have 2 points of intersection on the rays that make the angle. So now, if I give myself a little bit more length, remember this part you don't have to be precise about. You just give yourself the length. So remember, it's got to be over halfway to get me the intersecting arcs here. So I'm going to make quite a bit of an arc there because I'm not sure where that is. Come to this side and make the exact same arc. Now, draw a line through that intersection. Start with a vertex, draw through the intersection. And these two pieces should be the same. So, if this one is EDF, and if I call this one, I've already got A, B, C. If I call this one G, then we know that angle B is congruent to angle D. I could have said angle ABC. I could have said angle CBA. I could have said angle EDF or FDE. We also know that angle EDG is congruent to angle FDG because those are the two sections of the bisected angle. And this brings us down to the terms we need to define. Okay, adjacent angles. Think about what the word adjacent means. The word adjacent means next to. So adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. So in the same plane means coplanar. So two coplanar angles with a common vertex and side, but no common interior points. So if you're looking at it, these two angles that we have formed by bisecting the bigger one are adjacent angles because they're coplanar angles with a common vertex and a common side, but no common interior points. Okay, now, most of you know what acute angles are because you've studied them in the past. What is an acute angle? An acute angle is an angle whose measure is. So, 0 degrees is less than the measure of your angle, which is less than 90 degrees. If you notice, it cannot be 0 degrees and it cannot be 90 degrees. Okay, what about an obtuse angle? An obtuse angle is an angle whose measure is. Okay, so it starts at 90 degrees and it goes up to 180 degrees. It is not 90, it's got to be greater than 90 and less than 180 degrees. Okay, that brings us to right angle. A right angle is what? An angle whose measure is exactly 90 degrees. How about try to combine is and exactly, and it doesn't work very good. Okay, straight angle. Okay, think of a line. An angle whose measure is exactly. (180 degrees). So if you're looking at it, this is what we usually will call a line. So how do you know when you're successful? You know you're successful when you can identify different types of angles and you're able to copy and bisect any angle. Copy and bisect angles. And types of angles. And it's, other than the angle, the adjacent angles, this is by degree measure. Okay. Acute, it's between 0 and 90. It's not 0 and it's not 90, but it falls in between. Obtuse, their measure is greater than 90, but still less than 180. Right angle is any angle whose measure is exactly 90 degrees. A straight angle is an angle whose measure is exactly 180 degrees, and we usually call it a line.